Hey there, everybody. We are going to do a lesson here, and I've got my lesson sheet loaded up in Kami instead of a PowerPoint. We're going to learn about the equation of a circle. So to get motivated, and we have looked at relations like this earlier in the year, but check out this relation. And this relation is saying for this relation, the x and y values at any point to satisfy this relation have to add to 6. So we can write something to that effect in here. X and y values add to 6. If you wanted to generate some points on this relation, you just have to think of some numbers that add to 6. So that's not too bad for us to do. You can get some easy ones like 0 and 6 and 6 and 1, or 1 and 5, 3 and 3, 4 and 2, or any of the like 5 and 1, 4 and 2. But you can get some negatives like -2 and 8, or I think that's actually off my graph, but you get the idea. Something like, let's just go 2 and 4. Those are plenty. So 0, 6 is up off here. 6, 1 is over here. 1, 5, 3, 3, 4, 2. 6, 1. 6, 1 doesn't add to 6. 6, 1 is up to 7. Yikes. We're off to a good start. 6, 0, 5, 1. But as you can see, these points here form a line. And, this isn't a surprise to us. We reviewed how the equation of a line can come in many forms. This is one such form. Let's look at another one. X minus y equals 5. So I did the first one. Can you do the second one? Write a rule, see if you can find some points that work. So if you said something for the written rule, like the x value subtract the y value is 5, that's great. So let's think of some numbers. So like 6, 1, 7, 2, 5 minus 0, 4 subtract -1, and there's a lot of options. 5, already got that one. I'm just making random ones up. You might have different ones. 3 subtract -2, 2 subtract -3, something like even, let's just go 1 subtract -4. Let's continue the pattern there. 6, 1, 7, 2, 5, 0, and you can see the pattern there, 4 minus 1. So, I think most of you probably knew that'd be a line already. And of course, we could have sketched that line by putting it into y equals mx plus b form. So y equals x minus 5. As we've talked about earlier, relations don't have to be in the form y equals. The equation of a line can come in several different forms. So this brings us to our third example here. Check out this one. This one's a lot different than anything you've done before. In this one, we have not just x and y values, but with the squares. This rule is saying squares of the x and y values have to add to 25. So we're going to come up with some points together. that we can add to this graph and get an idea of what this looks like. So something useful to point out is that 5 squared equals 25. So points like 5, 0 would be on, because 5 squared is 25 and 0 squared is 0. So that would work. And something like minus 5, 0 would work too, because minus 5 squared is 25. And the other combinations work as well, 0, 5, and 0, minus 5. So those are 4 easy points to get. And check this out. Right away, we can see this isn't a line at all. This is going to be something different. Can you think of other numbers, x and y pairs, that when you square them and add them, you get 25? Give you a hint. Here are the perfect squares up to 5, 1, 4, 9, 16. Do you see a pair of them that can add to 25? If you recognized that 9 and 16 added 25, good for you. That means that the point 3, 4 is on this graph. Same with 4, 3. Same with something like negative 4, 3. Or even negative 3, negative 4, or 4, negative 3. These are just some, because any combination of these, when you square them, even with the negatives, you're going to get 9 and 16, and they will add to 25. So I have 3, 4, and 4, 3, minus 4, 3, minus 3, minus 4, 4 minus 3. So you can see we've got kind of a graph developing here. And I'm going to add just in a few more. So minus 3, positive 4. So just using the symmetry, and I know I'm going to get minus 4, minus 3, any combination of 4 and 3, right? And then 3 minus 4. And if we connect these points, what we can see is they form a circle. And moreover, this circle has its center at 0, 0, and it has a radius of, you can just see, from the center to the outside, it's 5 units. So what we'd like to move towards today is being able to recognize that equations like this give you circles, and that from the equation, there are some properties that you can get about the circle, namely its center and its radius. So let's continue, guys. So just to summarize, what kind of shape did you get? A circle. Where was the center? 0, 0. What was the radius? R equals 5. Now, where can we spot those things from the equation? Well, if you have an equation, x squared plus y squared equals some number, then that number on the right gives you the radius. It gives you the radius squared. So you can see in our previous example, the one we drew, that we had x squared plus y squared equals 25. Well, 25 is 5 squared. And so now you can see the connection between how we write the equation. X squared plus y squared equals r squared. The radius isn't 25. It's the root of that. It's 5. And whenever you have a circle in this form, the center of the circle is always at 0, 0. There are ways to describe circles where the center isn't at 0, 0, but it's a bit beyond the scope of this course. So the big thing you need to know, hopefully you're convinced from our little exercise up here, is that this kind of equation gives you a circle, a circle centered at 0, 0, the origin. And your big need to know is that you can get the radius from that n number by square rooting it. So let's do some exercises to cement that home. If you'd like to take a moment and see how well you understood that last example, can you write down the center and radius of these first 3 rows? Just give it a try. You can pause and unpause when you're ready. I'll assume you've had a chance to do that. Hopefully you all said they have their center at 0, 0. How about the radius though? In this first one, radius squared is 16, which means the radius is 4. So the big mistake students make with circles is that thinking that the number on the end is the radius itself. No, it's the radius squared. You have to square root it. So the radius squared for the second guy is 81. That's a circle with its center at 0, 0 and a radius of 9. And it's totally fine to have a radius that's not a perfect whole number. In this case, the radius is the root of 21, which is about maybe 5.6 or something. Oh, 4.6. Excuse me. Often we would actually just leave, if we were stating the radius of that circle, often we just would say the radius is the root of 21, and that's nice and exact. But it's also okay sometimes to give a decimal too. Can you work backwards? So given the center and the radius, can you come up with the equation? Now, I'll give you a bit of help. Because the centers are at 0, 0, it'll always be x squared plus y squared equals some number. But not just any number. We know that that is the radius squared. So can you work backwards here? You can unpause and pause. Pause and unpause when you're ready. All right. So if you said for this fourth one, x squared plus y squared equals 9, good for you. Because if 3 is the radius, then r squared equals 9. For 21, 21 squared, probably should know that. 441 is 441. In this one, if the radius is 21, then the radius squared is 441, and that's what we would see in the equation. And if the radius is the root of 7, well, when you square the root of 7, you just get 7. And so this equation would look like this. So hopefully you nailed that exercise, but again, we're cementing here that this equation always gives you a circle, its center at 0, 0, and its radius is the square root of what is on the right. So let's do, excuse me. Oh, you guys aren't boring me at all. Don't worry. I just have, you've heard me complain. Not complain. You've heard me say 2 kids, wife, job, house, dog. I'm just tired all the time. But let's do this question here. So we want to know that we want to determine the equation of the circle that has a center at the origin and passes through the point 6, negative 8. So just draw a very rough sketch here. Center at the origin. Here's our circle. 6, negative 8 is like somewhere down here. Now, how can we calculate the radius? Well, the origin is the point 0, 0. And the radius of a circle goes from the center to the outside. Is there a way we could find the length of that line segment from the origin to this point we were given? And hopefully you said yes. It's the distance formula, right? We can do the distance formula with these 2 points. Subtract the x's, 6 minus 0. Subtract the y's, minus 8 minus 0. Remember that when you square a negative number, you always get a positive. So we get 36 plus positive 64, and that equals the root of 100, which works out nicely to 10. So if we know the radius, just like the table above, we can state the equation of the circle. X squared plus y squared equals 10 squared, or x squared plus y squared equals 100. We would just write it this way. I just wrote the 10 squared as a bit of an extra help. All right, so another example in the books. Let's do one more. Here we have a circle, and maybe first I would just ask you guys, what would the equation of that circle be? It's centered at 0, 0, and its radius of 10. And don't think too hard. Maybe look at the question above. But yeah, this is the equation: x squared plus y squared equals 100. Notice that it goes through 6, negative 8, just like the example we did previously. So if you want to show if a point is outside or inside or on the circle, what you can do is you can just plug it into the equation. So let me show you what I mean by that. So this is the equation of our circle. And I'm going to sub in minus 5, 9. Now I want to look, do I get a number bigger than 100, smaller than 100, or equal to 100? So minus 5 squared plus 9 squared. What is that? That's 25 plus 81, which is equal to 106. And 106 is greater than 100. So what we've just shown is because when we plugged it into x squared plus y squared, and we got a number bigger than 100, that means it is outside the circle. So I'll just write a little statement saying that. A number larger than 100, this point is outside the circle. Right, of course, if we had got it equals 100, that means it satisfies the equation and would be on the circle. And if we got something less than 100, something kind of small, that would show that that point is closer to the origin and inside the circle. But guys, after this lesson, the things you should be able to do, you should be able to take an equation and immediately find the center and the radius of that circle. You should also, given a point that a circle passes through, be able to find this equation by finding the radius first. And also, you should be able to determine if a point is outside, inside, or on a circle by plugging it in and comparing that number to, in this case, it was 100. All right, and that's it for this video lesson. Hope you guys are staying well. Have a great day, and we'll see you soon.